Hi, this is Ritvik. I'm currently studying my master's in cloud computing. I'm from the college NCI. So I'm here to explain my project from the module Fog and Edge. I'm going to share my screen and going to the PPT. So yeah. So yeah, yeah. So this is my project. Title of my project is Mine Worker Safety Monitoring using Fog-enabled IoT architecture. So my main aim of my project, or like my main motive, is to provide the safety for the mine workers. Like mining is one of the most dangerous industries in the world. Like undergoing workers face risk like fires, toxic gases, overeating, and even health emergencies. In this situation, a few seconds can save their lives. So traditionally, cloud-only safety system face the latency due to the long network paths and limited undergoing connectivity. This makes real-time hazard detection difficult. Our solution, like my solution, use fog computing with IoT sensor to detect the ad and danger instantly. Like fog and edge, like it's something like it collects the IoT device data to the cloud. So in this, I'm not using any device, but I'm using the data uh, from my code. Like I have a simulation technique, so I'll be explaining that. So with that simulation technique, I'm going to save that data to the cloud. So my project, like mine workers safety monitoring using Frog and enabled IoT architecture, focus on building on a low latency, reliable safety system using Internet of Things, sensors, fog computing, and cloud integration. We'll be discussing and telling it in a clear way. So coming like I have the problem overview. These are my problem overviews, like mining in the hazards, like delays in the hazards, and need for the real-time monitoring. So these are the main three things. Like motivation and goal is, so in mining operations there will be lack of these two. One is latency and network contractions. So if I can mitigate this, we can save many lives and we can alert that. So this is my motivation and goal on the project. So now we coming to the sensors. Like this plays the most important role. These are my core sensors, like temperature sensor, smoke sensor, proximity sensor, biometric sensor, and CCTV sensor. So these are my main sensors. And coming to the architecture, this is my architecture of the project. So you can see the all the green things is the cloud and the data collectors and the sensors over there. So I'll be explaining that in a working example. Like you can see the smoke detection zone 3, fog notes the triggers, and camera activates alerts to the dashboard. This is the pretty much explanation of that architecture diagram. So in my system, I have the three-layer architecture, like sensor layer, fog layer, and cloud layer. So yeah, so now coming, already I said like I develop for developing this I need the two stimulations. One we call as a ifog stimulation, that is the basic cloud stimulation you needed. So for this I use the technical stack Eclipse, and my code is I use Java. So this is my basic setup of the things. Like you have all my libraries over here. And explaining of the code, I have kept the class here, which is called Mindwalker Safety. And in this, I have set many modules like to add my sensors, alert my sensors, and collect the data from the sensors. So once I run that, this gives the matrix of the collection of things. In this, the main three things is like energy consumption and cost of execution and total network usage. So this tells the matrix how good it is. Like it has in two cases. One is cloud, when you have the cloud, and when you don't have the cloud. So if I go to my PPT, I have just added the photos as well. It is pretty much same uh, in the console which I'm getting over here. So this is one type of simulation. Another type of simulation is from the IoT, like the Azure IoT. This is the like basic side. So we you go here and create an thing, and like if you go for the overview, you have here all my metrics. So you can see here manage how for today and the daily use quotas and how are the devices of that. So yeah, you can directly create the device in the manage device. For example, I have created the five things. To hard code this, I have created an code over here. So I kept the class here, and so I have created the name of that and the devices and the token. So the token we can find over. Yeah. So we can find over here, for example, temperature sensor, and or when you create that, you have the token, you can directly hard code there and you can get the values and you can read that values. So the two stimulations, like one is iFoc stimulation, which is I use for the Eclipse and Java for the setting of my sensors, and this one to get the dashboard results, which we call as an IoT. I use an IoT log and I use an API for this integration. So yeah, these are the two things which we use for this. So already we have discussed that if you have a cloud, true, you have the increase the energy and the network capacity and everything. If it is false, it won't be that good. So that is pretty much of technical view how we implemented for the better alerting of the sensor and sending the data and check or how the data is relevant. So in future development, we can add the gases using AI content fields and create AR and VI everything over to that. So this I have inspired from the paper this. So this is called an environmental safety and the production monitoring in the under governments. This is the paper which I got inspired how to take my project and everything. How in general I have focused on minus safety. So it says the environment or when it triggers everything over there. So it gives pretty much idea over that. And I have took one of the part how to give the safety for the miners and how to mitigate the things which they are going like the network latency and everything. So that is pretty much about like what I developed on that to provide the safety for them. So in conclusion, for fog enabled IoT system offers a renewable low latency solution for protecting workers in the adverse mining environments. By combining real-time local processing with the cloud analytics, we not only reduce the risk to human life, but also create an scalable architecture that can be applied to the higher risk industries. So it helps us to be more accurate and in a way of to mitigate the things like it gives the safety over to the miner. So it provide the safety and it can arise the thin layer between the safety and disaster in between. Like it can we never know when it is concluded. So conclusion it's like fog and edge IoT improve speed and safety in mines, like hybrid architecture ensures the return scalability and application to the hazard industry. So that is pretty much about my project, and thank you.